This video is about solving two-variable linear systems using an algebraic method called substitution. Hopefully you watched the other video about solving linear systems using elimination. This is just a different method. Some systems are more easily solved by using elimination. Some, using substitution, might be a little bit easier. Take a look at the format of this system. One variable is already solved for. We have x equals 6y minus 9. What's nice is we can take that 6y minus 9 and substitute it in for x into the other equation, because that's what x is equal to. The original equation said x equals 6y minus 9. So I can rewrite the second equation. Instead of 2x, I can call that 2 times the quantity, 6y minus 9. Plus y equals 8. That's the rest of the equation. Notice we've replaced out one of the variables. We have a single equation with a single variable. We can solve this. Let's distribute the 2. We get 12y minus 18 plus y equals 8. 12y plus y gives us 13y. If we add 18 to both sides, we get that 13y equals 26, so y equals 2. Of course, to finish solving the system, we would have to plug back in and solve for x. But it's nice that x was already solved for in this first equation. X equals 6y minus 9. So that means x equals 6 times 2 minus 9. It's kind of nice to have that set up here. So that would give us 12 minus 9, or x equals 3. If we wanted to write our solution as a point, we could call that 3, 2, x, y. So substitution is kind of nice, because right away you replace out a variable, and you only have a single variable equation to solve. It's nice that in this example, x was already solved for. Let's look at another example. In this example, you might have the instinct to immediately try to solve this using elimination, since all of our variables in both equations are on one side. But if you notice, we can solve for y in the top equation by subtracting 3x from each side, and right away we can get y by itself. Y equals 10 minus 3x. Now it looks like it might be easier to use substitution here, just with that single step of isolating y. Y is equal to 10 minus 3x, so we can substitute that in for y in the second equation. Instead of writing 3y, we can write 3 times the quantity, 10 minus 3x. Notice I just rewrote the second equation, but instead of writing y, I wrote 10 minus 3x. We now have a single equation with a single variable. We can distribute the 3, combine like terms, and finish solving for x. We get that x equals positive 4. We now can plug back in, and I'm going to plug back into the equation where y was already isolated. 10 minus 3x. And we get that y equals 10 minus 12, which is negative 2. So our solution, written as an ordered pair, was 4, negative 2. You might develop a preference for elimination over substitution or vice versa, but it's nice to know that usually one method is a little bit easier. Of course, we could have used elimination for this system here as well, but I think substitution might have just been a little bit faster. Good luck with systems!